Hey, welcome back. So today we're taking a look at Unit 4, exponential and logarithmic functions. We'll deal with exponents and logs, which are both actually inverse expressions of each other. So it'll kind of be a quick review of the idea of an inverse function for Unit 1. With the exponentials, we're going to take a look at properties of exponents first. So this is really going to be a review of some pre-algebra and algebra 1 concepts. We'll be able to move through this relatively quickly. So first up is your product of powers. This is where you're multiplying a common base together. There's exponents we'll add together. So like x to the fifth times x cubed, 5 plus 3 is 8, hence x to the eighth. So if there's a coefficient to also go with these like bases, the coefficients will multiply. 4 times 7 is 28, while the exponents will add. 6 plus 3 is 9. So that's 28x to the ninth. That's your basic product property. Power of powers is now where we raise a exponent to another exponent. So like we have x to the fourth to the third. Here the exponents will multiply together. So 4 times 3 is going to give us 12. All right, so we can see with this example we got power to a power then to another power. So just a string of multiplication. 4 times 2 is going to give us 8. So it becomes f to the eighth to the fifth. 8 times 5 is 40, so it's f to the 40th power. All right, so again, anytime you're doing power to power, you're just multiplying those exponents. Now, if we've got a product, an expression being raised to a power, each individual piece gets raised to that power. So the exponents would be multiplying power to power. The coefficient would then also get raised to that power and evaluated. So if I have negative 2x to the fourth y z cubed, and I'm cubing the entire expression, I'm cubing the negative 2, cubing x to the fourth, cubing y, cubing z cubed. Negative 2 cubed is our negative 8. X to the fourth to the third, multiply, we get x to the 12th. Y is really y to the first, so 1 times 3 is 3, hence y cubed. And then for z, 3 times 3 is 9, hence z to the 9th. So here we would be doing 3 squared, x to the fourth squared, y cubed squared. 3 squared is 9. X to the fourth squared is 8, y cubed squared is 6, so it's 9x to the eighth, y to the sixth. So we can kind of combine this into one big problem here, where we're raising individual expressions to a big power, and then we're going to multiply all those pieces together. Real quick, that negative f to the fifth, think of that as a negative 1 times f to the fifth. So the left side there, all that being raised to the fifth power, we'll get 32 f to the 20th, g to the 15th, and then times negative 1 to the fourth is just a 1, and then we'll have f to the 20th, g to the 16th. So now multiplying 32 times 1 is 32. Multiplying the bases means we add the exponents, so we'll get f to the 40th, and then g to the 31st. All right, so again, basic PEMDAS rule applies, work inside the parentheses, then we work out from there. Now, the quotient of powers is where now we are dividing two powers of the same base. We'll subtract the exponents. So x to the ninth over x to the fourth is 9 minus 4, which gives us x to the fifth. So if it's part of an overall expression, the coefficients, we reduce the fraction. Negative 3 over 9 is a negative 1/3. And then 6 minus 4 is 2, so it's a squared. 4 minus 3 is 1, so it's b. You don't have to write b to the first, you can just write b. And then 9 minus 5 is 4, so it's c to the fourth. All right, only the 3 is on the bottom because when we reduce negative 3 over 9, we get that negative 1/3. Now, if we have a fraction, or a quotient in general being raised to a power, we raise each individual piece of that to that power. So 2/3 to the fourth, 2 gets raised to the fourth, 3 gets raised to the fourth. So 2 to the fourth is 16, 3 to the fourth is 81. And as long as we simplify the fraction before we start raising to powers, you're going to have the simplified version of the answer. Because if 2 to the third can't reduce any further, there's no way when I multiply 2 4 times and 3 4 times, I'm going to get a fraction that has to reduce after that. But if I don't reduce first, then you're going to get a much larger number, and it's going to be a little bit harder to reduce the final answer. So for example, here, I'm going to reduce this whole thing before I cube it. So I'm going to get a negative 3 for negative 6 divided by 2. A to the first, b to the fourth, c squared. Now I cube and I get negative 27 a cubed, b to the 12th, c to the 6th. So you would still get the same answer if you cubed first, but then you'd have a much harder problem to reduce. Always reduce before you raise the exponents. Now, if the exponent is raised, if the number is being raised to the 0 power, as long as it's a non-zero number, then the answer is always going to be 1. So 15 to the 0 is 1. B squared over C cubed to the 0 is still 1. So this whole big mess right here, because it's being raised to the 0 power, is just quite simply 1. And that's it. Nothing fancy there, so just be careful. It's not 0, it's a common mistake. If something's being raised to the power of 0, the answer is 1. Part of where it's coming from that is very straightforward. Like if we have like x to the 4th divided by x to the 4th, according to logic, if I'm dividing the same exact expression together, I'm going to cancel it out and get a 1. But if I apply our exponent property, dividing subtracts, so 4 minus 4 is 0, we get x to the 0, which we know has to circle back and equal 1. So that's why, or at least that's one of the reasons why any number, or any fraction, any expression raised to the power of 0 is always 1, as long as it's not 0. If it's 0 to the 0, then that gets a little interesting. And then finally, we have a negative exponent. So if we have a negative exponent, we write it as the reciprocal of it as a positive exponent. So depending on where the exponent is determines how we're going to rewrite it. So if it's x to the negative 5th, it becomes 1 over x to the positive 5. Where if it's 1 over y to the negative 4th, it becomes just y to the 4th, no more fraction. Now, simplifying expressions with negative exponents, you're going to pretty much want to apply all your exponent properties first, multiplication, division, then rewrite the negative exponents that remain there, and just in general be careful work with negative exponents because the whole idea behind adding, subtracting, multiplying with our negative numbers. You're also welcome to simplify the negative part first and then deal with the exponent properties. It really is going to come down to your own personal preferences. I'll kind of show you what I prefer to work with for each of these next couple scenarios. So here we're applying our product properties for multiplying. So I'm not going to rewrite the negative exponents. I'm just going to go ahead and multiply and see what happens. 4 times 3 is 12. When multiplying, I add exponents. Negative 8 plus 4 is a negative 4 for x. For y, 3 plus negative 5 is a negative 2. And then for z, negative 5 plus 9 is a positive 4. So the final answer would then leave the 12 and the z to the 4th where it is, but then move x and y to the denominator as now positive exponents. All right, so again, anything that's a positive exponent to begin with, which the 12 and the z would certainly qualify as positive exponents, they stay in their location, the numerator, whereas the negative exponents move to the denominator because they are essentially in the numerator. This is like one big fraction over 1. If there's already a fraction, again, I like just going right to our property right there. We're applying the property, puts it in the numerator as the default when you subtract, and then we can just move it back down if it's a negative. So 8 over negative 2 is negative 4. For f, negative 3 minus negative 6 is a positive 3. Because you're doing negative 3 minus negative 6, that becomes a plus. For g, 8 minus 12 is negative 4. And then for h, 4 minus the negative 3, that becomes a plus, so that's a 7. So we can see there's only one term with a negative exponent, the g. The coefficient of negative 4, while a negative number, is not a negative exponent, so it doesn't move. It stays where it is, same thing with the f and the h, but g moves where to the bottom. And we get that answer right there. All right, so just make sure you're careful, apply your basic property, and then move it after you're done applying your different exponent properties. For this one, I am definitely going to simplify this expression first. So I'm going to go ahead and get this to be a 1 over 3. And then for the x's, 4 minus negative 3 is a positive 7. Negative 3 minus 6 is a negative 9. And then negative 9 minus negative 5 is a negative 4. And so all being raised to the negative 4th power. So you've got a couple options here. What I actually would like to do here is I'm going to rewrite them all as a negative exponent back into its positive format. So this really be x to the 7th up top, a 3, y to the 9th, z to the 4th on the bottom. And because the exponent on the outside is negative, that means I'm going to do the reciprocal. Well, let's just do that right now. Let's flip the whole thing, make it 3 up top, y to the 9th, z to the 4th on the top, x 7th on the bottom, and now raise it to the positive 4th power. Now I have absolutely no negatives in the problem in the slightest. 3 to the 4th is 81. 9 times 4 is 36. 4 times 4 is 16. 7 times 4 is 28. So this is like one of the scenarios where I actually would deal with negative exponents before finishing off the problem. And that's because I have negative exponents and I have to then do something with it on the outside, especially because the outside exponent is also a negative. All right, so if we're raising the whole thing to a negative power, we can just simply flip the whole inside and raise it down to a positive power instead. All right, so hopefully that was a nice little review for you from your exponents back in pre-algebra and algebra 1. We're going to need to use the exponents because we're going to talk about graphing exponential functions, and we're going to talk about solving exponential equations later on. So I'll see everyone next time for those concepts.